Today we're going to introduce the idea of factoring, specifically what is called a greatest common factor. So when you see the word factoring, which you'll hear a lot, all we're doing here in any type of factoring is undoing the multiplication process. So when factoring using a greatest common factor, let's recall the distributive property. Given a problem like this, where we have 2x in front of x squared plus 5x minus 7, if we were to distribute 2x through the parenthesis set, we would get 2x cubed plus 10x squared minus 14x. While factoring, we undo the distributive property. So if I gave you 2x cubed plus 10x squared minus 14x, I could divide them all by 2, and they all contain an x. That is the greatest common factor. When I divide that out, I am left with x squared plus 5x minus 7. Let's do a few more examples. Factor using the greatest common factor. Both of these terms are divisible by 11. When I divide them by 11, I am left with x minus 2. Negative 9x squared minus 15x. They are both divisible by negative 3, and they both contain an x. When I divide that out, I am left with 3x plus 5. 8x cubed minus 16x. Those are both divisible by 8x. When I divide that out, I am left with x squared minus 2. We can do the same thing when there's 3 terms. All 3 of these terms are divisible by 3, and they all contain an n. When I divide that out of all terms, I am left with n squared minus 12n plus 4. This is our final example, 4x squared plus 5y plus 8. These are only divisible by 1, and they do not contain the same letter. So this is what we would call prime, or not factorable.